Hello, sir. How are you doing?
I'm doing well. No sleeping, but I'm doing well.
Can I ask you something?
Yeah.
What tablet do you use for your notes and that whenever you give us classes?
What? Say that again?
What tablet do you use like for when you do notes and that?
Well, right now I'm using the screen that they gave us, the school screen thing, but usually it's a Wacom. Oh, sure.
It's because I don't know. I've been looking at tablets lately, and there's one, a Samsung A7, and it's like on sale on Black Friday. So I don't know. I'm thinking.
Yeah. So I use so it depends on what I'm doing. If I'm working off of one computer, I'll use this. Well, they don't. Looks like they don't have it anymore. They changed it. Wow, it looks really different.
I love iPads, but nah, they're too expensive.
Very expensive. So I have a Samsung. Mine's old. It's like a 2016 model. It's a Samsung Tab Tab A, maybe 10.1 Tab A. Yeah, it's this one. Let me share my screen so you can see. It's an older one, so yeah, it's a Tab A. It's this guy. It's an older one. I got the 2016 model. They cut, obviously they have newer models now, but I mean it works great for what I need it for. And now they have the tablets they come out with, they have a like a full size stylus now. Mine's a little stylus about that big.
Yeah, I've seen it.
Yeah, so if you can get a full size stylus on your tablet, I would suggest to do that because the little one kind of it cramps your hand. It hurts after a while. I don't know if the new one what
The
size they
one that
are.
is on sale is called Tab A7. Yeah, that one. 10.1, I think.
It's a good price. It's not bad. It's not bad at all. And for me, it worked just fine. The 2016 model.
The only bad thing is that it doesn't come with a pen, but I think I can get one maybe.
Well, let's see. Yeah, you're right. I don't see a pen on this one. So if it's not coming with a pen, if you get one of those those aftermarket pins, they don't work that well. Try to find something with a pin. If you're gonna do that, try something that's made for
Yeah,
with a pin. Like mine had a pin come with it. Like it had the stylus come with it. So it works way better than trying to find an aftermarket pin and get that to work.
yeah, I get you.
Does the 10S come with a pin? That one's really expensive though. Yeah, this one comes with a full size pin, the stylus, but it's way more expensive. It's like twice the price.
Yeah, I know that's the only one that they put on sale. The other one. Okay, that's it. Thank you.
Yeah. Okay, I think everybody's on now, right? All right, so let's get started. I only have about 40 minutes or um, how far we should be able to finish because the only real difference between this and what we've done, and I think I already said this, was that it's just talking about different types of interest rate, and we're talking about different concepts of money, but otherwise the equations for the most part are exactly what we've been using before. It's F given P or P given F and all that stuff. So it's not a whole lot that's new that we're looking at. It's just conceptually kind of how we're dealing with it. So in 4.2, this is one of the things we're looking at actual dollars versus constant dollars. And so this is a concept that can be kind of difficult to understand at first, but I found a video that explains it really well. And so after I go through these notes, we'll watch that video real quick, about 5 minutes long. All right, so actual dollars versus constant dollars. And so we've seen, right? We've seen that the purchasing power of the dollar changes over time. Right, so that's the idea where if I can buy 1,000 bananas with $100 now, it's going to cost me maybe $500 now to buy the same number of bananas, right? So it loses its purchasing power, and it takes more money to buy the same amount of product over time. Well, we need a way to compare purchasing power between different periods. For various reasons, and your book goes through a lot of those reasons. I'm not going to talk about today just for reasons of time. Well, so it could be 2 periods or more. I don't do that. All right. So what that means is that we're going to have to convert. Again, I'll show you a video on what this means. From actual dollars to constant dollars and vice versa. All right, so let's define these things as the book defines them, and then again, I'll show you that video. Actual or current dollars, which that's the variable for average or actual dollars, sorry. And it estimates the cash flow for year end caused by inflation or deflation. Okay. This is the actual amount that you're going to get paid yeah, this is the amount that you'll actually get paid or have to pay. Right? That's the actual amount that you're actually going to get paid or you're paying for or paying with. And again, I'll show a video because that can be somewhat confusing. Constant or a real, that's why I get confused, right? So I would get confused. Back in the day, constant or real dollars which is the variable a sub n prime. Right, so it's a constant purchasing power independent of time. So we're not really considering the time. And it's a measure of worth. Not amount paid, it's not the amount that's actually paid or received. So it's going to be dependent on a specific year, in the sense that it's the same idea as the purchasing power. At 1950, I could purchase so many things with $100. So let me show you the video, because I thought it did a pretty decent job explaining it. And did it really concisely.
This is a quick video over inflation, and it's going to be about how it relates to constant dollars, constant, and actual dollars. So what is actual dollars? Well, that's the actual amount I give you. Like if I said I'm going to give you $100, so what we want to mean by that is I'm going to give you $100 bill. $100 bill. So $100 bill. So that is the actual money I'm giving you. I'm going to say I'm going to give you that per year. So I'm actually, I mean, I'm kind of going a little overboard with the actual part, but I'm going to actually give you a solid $100 bill every year. So I'm going to give it to you initially at year one. So this will be years. This is be the value of money I give you. So I give you $100. So this will be money. First year, $100. Again, second year, $100. Now, that's me actually giving you a $100 bill. Now, how about instead I say, I want to give you a constant $100. Constant $100. $100. What that means is I want to give you $100 I want to give you the amount of money that is the equivalent of $100 year after year after year. So if you have inflation, and we're going to say our inflation is around 5%. How much money do I actually have to give you to keep it at a constant $100 value? So what that means is if we have where I initially give you the money, which is $100, how much do I actually have to give you that constant $100? So this will be the constant value that we're doing, and we're going to do the actual over here. So how much do I actually have to give you? If I want to keep it at a constant $100, well, I have to give you $100 then. However, the next year we have to take account for inflation. So again, I want to give you a constant $100, but I want to give you how much do I actually want to give you? Well, inflation says I have to give you 5% more, because now, well, it's not worth as much as it originally was. This $100 is losing value. So in our scenario, it's losing 5% of its value. So we have to up it by 5%. So this will actually be, so what we'll do is we have the $100. We multiply it by 1 plus the inflation rate, which is 0.05 to the power of 1. So again, that will give us $105. So now let's go to year 2. Again, I want to keep it with a constant $100. And what does that give us? Well, we have to take the constant we want, which is $100, and we have to multiply it by 1 plus 0.05 squared. So that will give us a new value. So I'm not sure what that one is quite. So calculator real quick. So we have 100, and we are going to multiply that by 1 plus 0.05 bracket. And then we're going to take that to the power of 2. Pardon me. So then we need to give an actual $110.25. So $110.25. So that at the end of year 2, you're actually getting that constant $100. This, what we want to think of as constant is just the value of it. So we want to have just a constant value of $100. Money changes in value. A dollar is not worth the same as it is a year later. But if we want to say, hey, I want to give you a constant $100, we're saying I want to give you a value of $100 at this time for the rest of the century or whatever. So that will change the amount of actual dollar bills you have to give. So that's the difference between inflation when you're dealing with constant and actual dollars. Again, the equation to find out how many actual dollars you have to do for some constant value at some time is the actual dollars is equal to the constant dollars times 1 plus the inflation rate to the power of the number of years, where n is the number of years. So we wanted to see the actual dollars we needed to give at year 2, so n is equal to 2, f is equal to 0.05, and of course c is equal to 100.
All right, so hopefully that's somewhat helpful. Basically, if you want, you can think of it as like, well, like what I've been saying is that at 1955 or whatever, this is how much I could buy with $100. I want to keep paying you so that you can keep buying, right? So what was the example? So $100 gets you 1,000 bananas. I keep using bananas, all right? So $100 gets you 1,000 bananas. I want you to be able to buy 1,000 bananas every single year. Well, the value of the dollar is going to go down over time. So I want to give you kind of the equivalent of that $100 so you can continue buying 1,000 bananas. So the first year it's $100 for 1,000 bananas. The second year it's going to be a little bit, the value of the money goes down, but I still want to give you the equivalent purchasing power to still buy 1,000 bananas. So I have to figure that out using the equation that they gave. So I want to give you the equivalent of $100 from last year. This year is going to be 105. So it costs $105 now to buy 1,000 bananas. So that's how much I'm actually going to pay you. But the worth, the purchasing power is represented by that initial $100 for 1,000 bananas. I hope that makes sense. All right. So how do we go from constant to actual? The equation is actual dollars is going to equal to the constant dollars times 1 plus F. Remember that that's the general inflation rate to the end. So let's just write that. And we have a couple of equations. Find that. I'm sure that I've written down here somewhere. To find the inflation rate, we could do CPI N is equal to CPI. Oops, where's the I? O times 1 plus F to the N. So if we're given the CPI, the index numbers for 2 different years, and we can use this equation here, where N is the number between 0 to N, right? Of course, N is the number of years. Right, and then going back, if we need to find, well, actually, not yet. So this is basically this equation, we're going to use the actual dollars is equal to the constant dollars, and we treat it like an F given P problem, right? So F would be the actual dollars, the constant dollars would be the present amount. F would be our interest rate, right? So general inflation rate, and N would be the number of years or number of pay periods or whatever. In this case, years. Okay, so those are the same equations. And then going the other way, actual to constant, we just solved that equation for A in prime. Right, that we just switched the thing around, and it's the same idea. So what am I actually going to get paid based off that purchasing power number for the constant? Or rather, what was the constant value that they're paying me would be inflation included. That sentence makes sense, I'm not sure. Then 4.3 was equivalence calculations under inflation. So right, so again, say it again. This is all about considering purchasing power instead of earning power. So we're focusing on purchasing power. Right, when we're dealing with like chapter 2, it was all about interest. How much interest am I earning? That was earning power. Now we're talking about purchasing power. I could buy this much stuff with $100 in 1950. What equivalent amount of money do I need now to buy the same amount of stuff? Okay, that's all this is about. That's the whole thing. That's all this is about, the whole chapter 4. All right, so we're going to have to do two things. We can go about this 2 different ways to figure this out. One, we can do a constant dollar analysis. Or 2, we could do a actual dollar analysis. Both will get you to the same result. All right. The difference is it's a slightly different approach, but the main difference is there's this different interest rate we use for each one of these. Kind of weird clicking or something. Right. One is the market interest rate. That's I. Sometimes called the nominal interest rate. So if a problem says nominal interest rate, it's the same as the market interest rate. And then we have the inflation-free rate. That's going to be I prime. And so you'll see that they're analogous to the others. The market interest rate is going to go with the actual dollar. The inflation-free rate is going to go with the constant dollar. Right? We have to identify. So when we're presented with a problem or we're looking at a cash flow, we have to look at the nature of the cash flow. And there's three cases, right? This is laid out. These three cases are laid out in the book. Case one, the cash flow is in constant dollars, or two, the cash flow is all in actual dollars. So when we look at the problem, everything's either constant dollars, one, or two, it's in actual dollars, or three, we could also see the situation where there's a mix of the two. Okay, and if there's a mix of the two, then we would just convert the actual to constant or the constant to actual, and then treat it like it's all actual or all constant, depending on what we do. Right, but those are the three cases that we're going to run into. We have to read, and the problems I skimmed through most of them just a while ago. Most of them say actual dollars or constant dollars. They're going to tell you very obviously what it is for the most part that I saw. So you won't have to do too much guessing for that. All right, for a constant dollar analysis, it's very straightforward. We're going to have the present worth is going to equal to the payment times 1 plus I to the negative n. All right, so we're using the inflation, I prime, sorry, the inflation-free interest rate. Right, so something you might look for is the problem says something like no inflation. And it might actually just say also constant dollars, right? You're giving this constant dollars. And that's it. That's the equation. To understand what's going on, we were just making payments, constant dollar payments. How much is the present worth? There it is. Actual dollars. Right, there's a couple of steps that you would take if you wanted to do this. The most basic approach would be to convert the actual dollars to constant dollars by kind of ignoring the general inflation rate. And then we can use the inflation-free interest rate to find P, and using the same equation we did for constant dollar analysis, right? So you convert it to constant dollars and then you use the constant dollar analysis. Or we can streamline that process a little bit and use this equation. So we have we can use the market interest rate, which kind of does both of those steps in one, okay? So we'll end up with present value is equal to N, actual dollars, 1 plus I to the negative N. All right, so it looks very similar, but I is going to equal to, the market interest rate is going to equal to I prime plus the general inflation rate plus those two things multiplied together. All right, so that's going to give us our market interest rate. Oh, if I prime and F bar are relatively small, then we could reduce that equation down a little bit so that I is going to equal to I prime plus F. We can knock off that last term because it's going to be too small. Right, so if I prime was 0.01 and F was 0.01, it's going to be 0.001. It's going to be too small to affect the final number, so we can just knock it off and ignore it. Okay, so again, we can still think of this in terms of this is how much it was worth at this point. I want to know how much I'm getting now. And so the same idea for chapter 2, it's all follows the same. It's just that the interest rate, that's really where it all comes down to, is what that rate is. So let's look at some problems. I just got a couple and then I've got to go because give you a minute to write that down. Oh no, well, you guys look it up in your book and just write down the problem as we go through it. Problem 4.6. The average starting salary for engineers was $5,000 a year in 1955. John, a mechanical engineer, got an offer for $72,500 a year in 2017, knowing that the CPI, so let me write that down, CPI for 1955 and the CPI for 2017 are 26.87 and 243.73 respectively. What is John's real salary in terms of constant $1955? All right, so if you were being paid in 1955, how much would he get? That's really what the question's asking. If you were getting paid in 1955, how much would he get? So we're looking for the constant dollars, A and prime. Okay, so right now he's getting the current the real dollar. I don't know. I don't want to do that. It's kind of like a future value because we're looking into the future into 2017. He's getting paid $72,500. You can think of it that way. So that's going to be equivalent to the real, or to the what he's actually getting paid, right? That brain's all over the place. All right, so we have to find F bar because our equation P given F, sorry. P given F. Right, I have this. I have this. I can figure that out. That's going to be 2017 minus 1955. I think that's 62. Yeah. Okay. But I have to figure out F. Need F bar. Okay, so I had an equation. CPI N is going to equal to CPI not 1 plus F to the N. Okay, so I had CPN, that's at 2017 is going to be 243.73. CPI naught is going to be 26.87. 1 plus F bar is what we're looking for to the 62nd power. Y'all do that however you want to solve for it, but you should get 3.62%. Okay, so F bar is 3.62%. So now we can take that number and we can plug it in. We can plug it in there. And we already have an N, so that was 72. 101 plus 0.0362 to the 62nd power. So that's 7,900 and I think $93, right? So the average engineer got paid $5,000 in 1955, and he would have gotten almost $3,000 more than the average engineer in 1955. Okay, so again, this is, I mean, we're not dealing with the interest rates in terms of loans and savings accounts and stuff like that, but the idea is still the same. We're looking at a past amount. We want to know what the future amount is, or vice versa. Same ideas, just apply to different concepts. Same procedures, apply to different concepts, right? Problem 414. Some water. Let me grab some water. All right. It says an annuity provides for 10 consecutive end-of-year payments of $72,000. So right off the bat, we've got an N. Happening. N is equal to 10 because we've got 10 consecutive payments. End-of-year payments of $72,000. We're dealing with a market interest rate, so this is A sub N. What is the annuity worth in terms of a single equivalent amount of today's dollars? So it's kind of like a present, a future amount. So this is kind of a future amount, or it's a no, the opposite. We're going to calculate the end of year payments in 2000. What's it worth in today's money? So present worth. Right. We have the average general inflation rate. F bar is 0.04, and the market interest rate I is 0.08. All right, so what's the present worth? So we've got P is equal to, make sure I'm using the right equation here. Yeah, P given A. Yeah, that's right. We've got $72,000, given A. Here's the question though, which one of these do we want to use? Do we want to use the 8% or the 4%? That's the question. We're looking for an equivalent amount in today's dollars. And we don't see general inflation rate. So we don't care about the inflation rate because we want today's dollars. Okay. So that's going to be 8%. So we just want to use the 8%, the market interest rate of 0.08, and that's over 10 years. Right, in the table, or you can calculate this by hand, or you can put it into an Excel file, which is also a pretty handy way to do that. You should get $483,126. Okay, so not too bad. All right, so that's chapter 4. I think I got you homework on just the first section. I'll work on getting some homework for the second and third sections as well. I'll put maybe 2 problems per section, so that'll be another 4 problems. That'll be due next. When did I have this? It's 11th. We'll have it due next Tuesday. Next Tuesday. All right, so I've got to run. We got a good 40 minutes in on this. I did want to do one more problem, but I wasn't able to get it ready in time, and I don't want to do these problems just off the cuff. So we'll stop there, and maybe if we have questions next time, I can cover another problem or something. All right, so I've got to go. Are there any questions before we head out?
No, sir.
No, sir.
Ready? We'll see you on Thursday. We'll see you on Thursday.
See you on Thursday, sir.
See you,
Bye,
sir.
sir.